Hi, now this is for sure is going to be the last one, the last part. And this is about images forming by lenses. Okay, lenses, they use refraction because we know that light is going to go through the glass and is going to be, having like the idea here or the concept that is used, it is the refraction. Okay, now we have so many types of I would say lenses. They are made from plastics or glass, many types of these. The ones that we are going to focus on today is the double convex and the double concave. And also one more approximation we are going to make. These are called thin lenses because if we're gonna assume that they have they have kind of the thickness, this is gonna be like I would say it's a like kind of a different story because it's gonna have more refractions. Okay, also I represent, this is a short way of representing the double convex, and it's easier to use it when we, when we're gonna draw the cases. This one has 5 cases, very similar to the concave mirror, and this one has only 1 case, very similar to the convex mirror. Now, one thing that maybe we need to also define here, it is the power P of a lens. It is the inverse of its focal length, and that is P equals 1 over F. And of course, it has the units that we, we say either meter minus 1 or that actually is D parts D. Okay, these both are really units that we are using. Again, we are going to use the same notation. I will say this one, it has the focal length positive. This one, it has the focal length as negative. Anytime that the image is going to form in the same side as the refracted light here, refracted, is going to be a real one. Otherwise is going to be virtual. Now for lenses, and now this for double convex, the first beam of light, I want to have it parallel to the principal axis here, or the optical axis, and then is going to refract through the focal point. The second beam of light, it is going through the center of the lens, therefore it will have no refraction at all. They're going to intersect here, and therefore you can see that I have a real image. It is inverted and it is reduced. I can also very easily apply the rule here, 1 over U plus 1 over V equals 1 over F. And for me here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then for you, it is 1 over 10 centimeters. And I want to find what is V, and the focal length is 3. Then 1 over V equals 1 over 3 centimeters minus 1 over 10 centimeters. Okay, let's do the math. This is 0.1. and therefore is gonna be 0.233. Okay, and let me okay, then this is really 1 over this value. You're gonna take 1 over this value, and then here let me write this in the blue here. V here, it is 4.29 centimeters. And if we look here, 1, 2, 3, 4, almost like 5. Of course, my straight lines are not very straight. Okay. And what I can do is, I know that I can divide by 10 to get the magnification, and the magnification here, it is negative 0.429. Okay, which means that the image is going to be reduced. It is inverted because it is negative, and it is it is real inverted and reduced. This is the case when we have the object at the 2f, which is double the focal length, and you can see that the image is gonna start increasing in size. Then it is real inverted, same size. When the object is at the focal point, we're gonna have it no image at all, and after that we're gonna have the image virtual, upright, and enlarged. Then this is the only case that this is really upright and enlarged and virtual. Now this is here for a double concave lens, and that one, it is actually the only case that we have. It is virtual, upright, and reduced. And again here, showing you what is really the, I will say, at the same definition as the power of the lens. Okay, then this is really things that we need to know in this chapter. And let me here do one more thing, which is I'm gonna have like just one problem maybe. Okay, let me have the problem here. I'm gonna write it for you. A concave okay, I did do for actually mirrors. I want to do for lenses. Okay, therefore I'm gonna say, and remember always the approximation that we are assuming that it is thin. A thin converging lens is found to form an image of a distance building 24 centimeters from the lens. If an insect is now placed 16 centimeter from this lens, how far from the insect, will its image be formed? Okay, now here I will say, well, like again, we are going to, like here, let's say this is my lens is here. Okay, the thing is, the light is coming from very far. This is distant building. Then it is very far, right? Which means my U, it is kind of infinity. And it is forming at the image somewhere, okay? The image is gonna be here, and it is 24 centimeters from the lens. What I can do is I can say 1 over U plus 1 over V equals 1 over F. This is a way of measuring the focal length of the lens. This one is going to be 0 because 1 over a very large number. And therefore here we're going to find that V equals F, and then the focal length of this lens is 24 centimeters. And then now here, let's go back to the insect. Then for the insect, I have, this is my lens, and its focal length F here, and it is 24. I know that the insect is at 16 centimeters from the lens, then it is somewhere here maybe. Okay, and I am looking for what is gonna be the I will say the image. Where is the image? And what is the distance between the image and the object? Now, one thing here that is really important is I need to verify the information that I know. When the object is at a distance less than F, then it's gonna be a virtual image. Then I'm gonna expect that the image is gonna be forming somewhere here, all right? Now let's do the math. 1 over U plus 1 over V equals 1 over F. And here 1 over U, 1 over V is 1 over F minus 1 over U. And that is going to be 1 over 24 centimeters minus 1 over 16 centimeters. Then what I can do is, sorry. 0.0417 minus 1 over 16, 0.0625, and of course it's going to be negative because it's going to be on the same side here. Then that is negative 0.0208, and I'm gonna get 1 over this number. This is gonna be negative 48.1 centimeter, and that means that if the insect here, this is the object at 16, this is like the image is gonna be, of course, is gonna be okay at 48.1 centimeter. And then what I can do is I can subtract now 48 minus 16, and that is gonna be V, that distance. It's not V actually, this is the distance between the image and the object. and is gonna be 48.1 centimeters minus 16 centimeters, and that is gonna be 32.1 centimeters, which is 32 centimeter based on significant figures. All right, okay, another one. Okay, the last one here is gonna be an object is placed 10 centimeters from a convex lens of focal length 20 centimeters. What is lateral, we call it lateral magnification of the object? Is gonna be here first. Okay, we know that magnification is negative V over U. Therefore, I need first to find V. 1 over 10 centimeters plus 1 over V equals 1 over 20 centimeters. And then 1 over V, it is 1 over 20 centimeters minus 1 over 10 centimeters. 1 over 20 and that is going to give me negative 0.05, and then V is going to be 1 over this number, which is negative 20 centimeters. For magnification, minus V over U, and that is going to be negative, and then here negative 20 over 10 centimeters, and that is going to give you a magnification that is 2. All right? Okay, then thank you and have a great day. This concludes chapter 25.